Alright guys, welcome back. Today we're going to talk about areas of similar figures. We have been talking about similar triangles, similar figures, and scale factors of their length, but we have only been comparing the similar shapes in terms of their length. We haven't really looked at their area yet, so today we're going to take a closer look at the areas. Now first of all, we have two examples. The first one, we have two rectangles. What is their scale factor? Well, again, by convention, we're going from the top to the bottom, so from 2 to 4 or from 5 to 10, we're going to get 2. The area of A though is 2 times 5 equals to 10. Whereas the area of B is actually 4 times 10 equals to 40. Okay, we'll leave that aside for now. Let's move on to the circle. In this case, our scale factor, we're actually comparing the scale factor from the radius to the radius. Okay, we're only comparing the one-dimensional length. We're only comparing the length. We're not really comparing the area or anything yet. So we're going from 7 to 3. 7 multiplied by 3 over 7 will give you the 3. So that's why the scale factor in this case is 3 over 7. The O area is going to be pi r squared. In this case, my r is 7. So pi 7 squared. In this case, I'm going to get 49 pi. The new area, we're going to have pi 3 squared. In this case, I'm going to get 9 pi. Now, if you compare the 10 and the 40, which is a new area, I actually multiply by 4 in this case. Whereas in this case, if I want to go from the old to the new, I actually multiply by 9 over 49. Okay? So as you see, it's not actually exactly the scale factor that I'm multiplying in order to get from the old area to the new area. So that means we actually have a subtle, slightly different relationship between the old area and the new area. So if you look at a more general picture in this case, for example, from the triangle to another bigger triangle, in this case our scale factor is k. The O area is the base times height divided by 2. Now the new area will be, again, your base is now kb times your height is kh. And now I want to divide it by 2. Okay, this could be written as k squared times bh over 2. But you notice that this ph over 2 is exactly my area of A. So the general rule over here is, if you want to go from the O area to the new area, you do actually need to multiply by, instead of k, you have to actually multiply by k squared. So for side length, you have old side length times k equals to new side length. But for area, we actually need to multiply by k squared. Now let's take a look at a few examples. Again, pause the video if you like, we'll come back together. Now you see that the scale factor in this case is, again, by convention, we're going from the left to the right. My scale factor is equal to 10 over 6, which is equal to 5 over 3. That means you need to multiply from A to B. In terms of side length, you multiply 5 over 3 from A to B. That means, if you want to go from the area of A to area of B, you do actually need to multiply by 5 over 3 squared in order to get to area of B. So we know our area of A already. We have 18 times 5 over 3 squared. This is 25 out of 9. That gives me the area of B, which is x in this case. So there you go. X equals to 18 times 25 over 9. You cancel the 9 out, you got 2. X equals to 50. Part B, scale factor is k. I don't know how much I need to go from 4 to x. But one thing I know is, if I have area C, I need to multiply by my k squared in order for me to get to area D. So we have area C, which is 12, times k squared equals to 27. So we can solve for our k squared. K squared is equal to 27 over 12. If you divide both top and bottom by 3, you're going to get 9 over 4. It looks good, because k in this case, we can write that as 3 over 2. It's a pretty nice number. We're not done yet, because we want to find out what x is. Okay, x is equal to, because it's length, we just need to do 4 times rk. And therefore, this is equal to 4 times 3 over 2, which is equal to 6. Question number 2, this one is a little bit trickier. Pause the video if you like, and whenever you're ready, we'll go over it together. So now the first thing that we notice is we actually have triangle ACE similar to triangle BCD. In this case, we can actually calculate our SF. The scale factor from the small triangle BCD to the bigger triangle ACE is equal to, you're going from 5 to 7 actually, so we're having 7 over 5. So we can use that to solve our questions. Part A, what is the area of triangle ACE? Well, you know that if I'm going from triangle BCD to triangle ACE, I need to multiply by 7 over 5. So that means if I have the area of BCD, which is 6.4 in this case, if I multiply that by 7 over 5 squared, because we're comparing the areas now, I will get to my triangle ACE, right? So in this case, we have 6.4 times 49 over 25. That would give me the area of ACE. So in this case, area of ACE will be equal to 12.544 centimeters squared. And part B, if you want to find out the area of ABDE, well, the area of ABD, if you notice, it's just this part. Basically, the leftover if you subtract the bigger triangle ACE by the smaller triangle BCD. Okay, so this is equal to triangle ACE minus triangle BCD. And we know both of the areas. So we can have 12.544 minus 6.4. And that's going to give me 6.144 centimeters squared. And that's it. Question number 3. Again, pause the video if you like, and we'll go over it together. So the keyword is actually show. That means we actually need to prove something. So let's name something just for our convenience. We'll call it MPA. How about that? We'll call it RSB. So we actually need to prove everything, including the similarity. Okay, we notice that these the blue triangle and the red triangle are similar for sure, but let's prove that. Okay, it shouldn't take so long. First of all, MPI angle is equal to SRI. Okay, it's because we have alternating angles. And second of all, we have MIP equals to SIR, and that's because we have opposite. So we have triangle PIM similar to triangle RIS, and that's AA. So now if we let RS equals to B, MP equals to A, we will realize that your A can actually be written as B over 2. And the reason behind that is because it's a midpoint. Okay? Because of the midpoint, your A is basically half of your B. Okay, so in this case, my SF scale factor from the small triangle PIM to the bigger triangle RIS is equal to this B, the bigger one, over the smaller length, B over 2, which is equal to just 2. Okay, so you realize that the side length is actually twice, okay, from the blue to the red. That's basically saying that my area, the area of the big one, the area of triangle RIS is equal to the smaller area of PIM, multiplied by K squared. Okay, notice that it's K squared now because we're comparing area. Okay, so in this case, your area of RIS is actually equal to, in this case, area of PIM, multiplied by K squared. Your K is equal to 2, okay, so 2 squared is equal to 4. Therefore, you are actually done. This is how you can prove that the smaller area is multiplied by 4 is going to give you the big area. That's basically saying your big area is 4 times of the smaller one. And we're done. So that's it for today. I'll see you guys in the next lesson. Peace.